Hi, welcome back to my channel. Let's compare MongoDB, AWS DynamoDB, and AWS DocumentDB today, and find out which NoSQL database solution should you use in the AWS. These three NoSQL databases all provide cloud solutions. MongoDB 1.0 was released on February 2009. Its SaaS solution MongoDB Atlas was announced June 2016 and made generally available in 1 year later on AWS, GCP, and Azure. AWS DynamoDB was announced on January 2012 to support key value and document data structures. AWS DocumentDB also supports document data structures with limited support for MongoDB workloads up to MongoDB version 3.6, which was released in 2017, and version 4.0, which was released in 2018. At the time of this video, MongoDB is the leading NoSQL database solution in the market. But DynamoDB and DocumentDB, especially DocumentDB, have been growing significantly in the past 12 months. MongoDB is a free and open-source cross-platform document-oriented NoSQL database program. It uses JSON-like documents with schema to store the data. MongoDB can provide high availability with the replica sets. A replica set consists of 2 or more MongoDB instances. Each replica set member may act in the role of the primary or secondary replica at any time. The primary replica is the main server, which interacts with the client and performs all the read-write operations. The secondary replica maintains a copy of the data of the primary using built-in replication. When a primary replica fails, the replica set automatically switches over to the secondary, and then it becomes the primary server. MongoDB uses the concept of sharding to scale horizontally by splitting data across multiple MongoDB instances. MongoDB can run over multiple services, balancing the load and/or duplicating data to keep the system up and running in case of hardware failure. MongoDB Atlas is MongoDB's cloud version that supports on AWS, Azure, and GCP. It's a fully automated cloud service engineered similarly to the AWS DynamoDB, such as on the infrastructure provision, database setup, ensuring availability, global distribution, backups, and more. Also, it has easy-to-use UI and API, so you can spend more time building your applications and less time managing your database. Now let's go through the AWS DynamoDB's high-level architecture. AWS DynamoDB is AWS fully managed NoSQL database service. It allows you to offload the administrative burdens of operating and scaling a distributed database so that you only have to worry about the hardware provision, setup, configuration, replication, software patches, or cluster scaling. DynamoDB supports key value and document data structures. DynamoDB runs on the fleet of AWS managed servers that leverage solid-state drivers, SSDs, and it's automatically replicated across multiple availability zones in the AWS region, which providing the built-in high availability and data durability. This platform decouples performance from table size and eliminates the need for the working set of data to fit in the memory while still retaining consistent low-latency response to the queries. Now let's move to another AWS fully managed document NoSQL database service, AWS DocumentDB. It provides MongoDB capability to easily set up and operate the mission-critical MongoDB workloads at scale. DocumentDB is not based on the MongoDB server, but more compatible with the MongoDB API. It runs on the top of AWS Aurora backend platform. It decouples storage and compute, automatically grows the size of your storage volume as your database storage needs grow. Your storage volume grows in the increments of 10 GB up to the maximum of 64 terabytes. You don't need to provision any excess storage for your cluster to handle future growth. It lets you scale the compute and memory resources for each of your instances up and or down. Computer scaling operations typically complete in a few minutes. On the instant failure, DocumentDB automates failover to one of up to the 15 DocumentDB replicas that you create in the other availability zones. If no replicas have been provisioned and a failure occurs, DocumentDB tries to create a new DocumentDB instance automatically. The backup capability in the DocumentDB enables point-in-time recovery for your cluster. Now let's compare AWS DocumentDB and MongoDB Atlas first. AWS DocumentDB is a long-relational database service designed with MongoDB API capability. It supports many MongoDB 3.6 and 4.0 APIs, but not all of them. If you are using the MongoDB in your current on-premise or on the AWS EC2, you should review its support in MongoDB APIs, operations, and data types before your migration. AWS does provide a DMS database migration service to migrate MongoDB databases running on-premise or on the AWS EC2 to the AWS DocumentDB. Keep in mind, MongoDB server is more powerful than AWS DocumentDB. Largest Atlas instance can support up to 128K concurrent connections. It supports full sharding. It supports global clusters with up to 50 replicas per shard across multiple regions. AWS DocumentDB, on the other hand, is running on the top of Aurora backend platform. It supports a single primary instance across 3 availability zones with up to 15 replicas. However, because AWS DocumentDB's storage and compute are separate in its architecture, a cluster with a single instance is highly durable. Durability is handled at the storage layer. As a result, an AWS DocumentDB cluster with a single instance and one with 3 instances achieve the same level of durability. This storage and compute decoupled architecture also provides the advantage on its pricing model. I will go through the pricing models later. Now let's compare AWS DynamoDB and MongoDB. DynamoDB and MongoDB, on the other hand, have many differences. I listed the terminology on 2 databases so you can cross-match them. DynamoDB uses table, item, attribute, primary key, secondary key, which match the MongoDB's collection, document, field, primary key, secondary key. AWS DynamoDB data model is a key value and the document data with JSON support. MongoDB using the BSON, which is a JSON-like document. DynamoDB supports 2 different kinds of primary keys. The partition key is a simple primary key, or the composed primary key with a partition key and the sort key. MongoDB, on the other hand, automatically assigns the primary key to a document upon insert. There is a big difference on the indexes of 2 NoSQL databases solutions. AWS DynamoDB indexes are provisioned separately from the data. You can set up 2 kinds of secondary indexes in the DynamoDB, global secondary index and local secondary index. Global secondary indexes are defined at any time with a different partition key and different sort key. Local secondary indexes must be defined when a table is created with the same partition key and the different sort key. You can set up to 5 GSIs and LSIs per table. You should spend some time to think about the GSIs and LSIs when you create the database based on the access patterns. The indexes and also the data integrity will affect the cost. You can learn more details in how to design AWS DynamoDB data modeling from my blog. MongoDB's indexes, on the other hand, is pretty easy and straight. You can add secondary indexes on any field. Indexes are consistent with the data. Indexes and strategies include compound, unique, array, partial, TTL, geospatial, sparse, hash, and text. On data query, DynamoDB can do key condition expression, filter expression, and sort. MongoDB also can do fields projections, sort, and field condition. I listed the supported data types of each NoSQL database solution for your reference. MongoDB can support more data types than the AWS DynamoDB. Data in the DynamoDB is eventually consistent by default. There's no data validation. There's actual cost on the strongly consistent. MongoDB, on the other hand, the data is strongly consistent by default. Native data validation is included. Applications can optionally read from secondary replicas where data is eventually consistent by default. Both solutions support point-in-time recovery. DynamoDB has DynamoDB streams with point-in-time recovery. MongoDB NS includes continuous queryable backups with point-in-time recovery. On the replication standpoint, DynamoDB synchronously replicates data across 3 AZs in the AWS region. DynamoDB provides the DynamoDB streams with the global table option. MongoDB automatically maintains replica sets, multiple copies of data that are distributed across servers, racks, and data centers. On the programming standpoint, AWS DynamoDB only supports asynchronous programming, but there are lots of code templates and good documentation, so you can start to run your codes in a very short time. It doesn't support the aggregation function, so if you wanted to do the aggregation on DynamoDB, you could export your data to the AWS Redshift or AWS EMI, then do it over there, or enable the DynamoDB streams, then execute the triggers of Lambda functions to populate aggregation data into a separate table. MongoDB, on the other hand, supports both synchronized and asynchronous programming. Also, it provides 3 ways to perform aggregation: the aggregation pipeline, the MapReduce function, and the single-purpose aggregation methods. AWS DynamoDB and DocumentDB are fully managed AWS services. MongoDB Atlas is a database as a service on the public cloud, so you don't need to worry about installation and the database management tasks such as hardware provisioning, patching, setup, configuration, backups, or scaling. All 3 solutions have comprehensive security defined and also meet the compliance standards. From the security configuration standpoint, AWS DynamoDB and DocumentDB security setup are easier than the MongoDB NS. Data protection on both encrypting data at rest and data in transit with key management. You can use AWS IAM and set up the role-based access management. MongoDB provides both a MongoDB security checklist and a MongoDB NS cloud security setup for you to follow. Setup security on the MongoDB does take time. One thing I like about AWS is that you can build the serverless web application to access DynamoDB. You can even add the AWS Cognito to manage users' access or set up a web identity federation with identity providers for authentication and authorization. Even MongoDB has MongoDB Stitch to support the serverless platform. but it is a separate product from MongoDB NS. Now let's take a look at the pricing model of each solution. AWS DynamoDB's pricing model is complicated in multiple dimensions, such as read-write requests, data storage, backup restore, global tables, other AWS servers if you need, such as Kinesis, Glue, S3, DynamoDB DAX, DynamoDB strings, and data transfer, etc. You can get AWS DynamoDB hands-on experience on the AWS free tier account. AWS provided a detailed pricing example. In this example, the total monthly charges for a single region DynamoDB table is $100.05, and for two regions are $215.68. Now let's move to the AWS DocumentDB's pricing model. DocumentDB's pricing model is in the 4 dimensions: on-demand instances, database I/O, database storage, and backup storage. DocumentDB is not available at AWS free tier account. DocumentDB is more expensive than the DynamoDB. Let's use the AWS DocumentDB's pricing calculator to estimate the cost. Let's select the DB I4 large for the instance type with the 3 replicas, 80 GB storage with 200 million IOs per month, and 80 GB for backup storage per month. The estimated total monthly cost is $656.31. I will show you the MongoDB Atlas cost with the similar setup. MongoDB Atlas's pricing model is relatively straightforward on the RAM, data storage, data transfer, and add-on services. MongoDB Atlas sharded clusters is free. You should check this offer to get a MongoDB hands-on experience. Dedicated clusters start as low as $57 per month. Dedicated multi-region clusters start as low as $95 per month. Let's take a look at the estimated cost of Atlas with the similar setup as DocumentDB. It deploys MongoDB on AWS US East region with the 3-load replica set of M40S and run it 24/7 for 1 month using the included 80 GB of standard block storage. The estimated cost would be $946.79. Overall, from the above examples, the cost of DynamoDB is much cheaper than the DocumentDB and MongoDB. However, if the read and write capacity or the item size are increased, the cost of DynamoDB will be increased dramatically. You can take advantage of DocumentDB's separate storage and compute architecture if you need more on the storage than the compute. Keep in mind that MongoDB NS cost stay the same until you scale up the storage needs. In conclusion, MongoDB still is the leading NoSQL database solution in the market. MongoDB provides more features such as data validation, indexing strategy, query operations, and more data types than DynamoDB. MongoDB NS cost stays as the same until you scale up the storage needs. AWS DynamoDB starts with the lowest cost in these 3 solutions, easy setup and maintenance on the security and tables. DynamoDB uses asynchronous programming with the great coding document. However, if the developers are uncomfortable with the asynchronous programming, then DocumentDB and MongoDB may be the good options. MongoDB NS and AWS DocumentDB costs are easy to predict. If you are using the MongoDB in your current on-premise, the quick cloud migration is lift and shift to the MongoDB NS. You can also migrate MongoDB to AWS DocumentDB with AWS DMS. But you should assess the used MongoDB APIs, operations, and data types in your current environment and estimate the cost before the migration. Thanks for watching, and as always, subscribe to my channel for more great cloud computing learning tips. See you next time.